Hello and welcome to the Random of Science, and today we will discuss the origins and the fundamental concepts of trigonometry. Trigonometry comes from the Greek words trigonon and metria, which means triangle and measurements respectively. And based on those words, we could know the meaning of trigonometry, which is the measurements of triangles. But what are we actually measuring? We measure the elements that a triangle has, the sides and the angles, and their relationship with each other. Now, do you know who is the father of trigonometry? He is Hipparchus of Nicaea. He is considered father of trigonometry and used it to determine the size and distance of the sun and moon from the earth, and among other things he also compiled a table of chords of angles, which is similar to the sines. Trigonometry is divided into the areas such as plane trigonometry and spherical trigonometry. Plane trigonometry is on the two-dimensional plane. Triangles found on two planes such as on the x and y axis. While spherical trigonometry is on the three-dimensional plane. For example, triangles found on spheres. Which are present on three planes such as on the x, y, and z axis. But for this lesson, we will focus on plane trigonometry. Triangles can be classified into two. First one is by angles, where we have a right triangle where there is one interior angle that measures exactly 90 degrees. And oblique triangles that are further subdivided into acute triangles where all interior angles are less than 90 degrees, and obtuse triangles where we have one interior angle that measures greater than 90 degrees. And the other classification is through the sides. One is the Ischoline triangle where there are no equal sides. The other one is the isosceles triangle where there are two sides that are equal. The last one is equilateral triangle where all the sides are equal in measurements. Before we go into solving problems, let's try and refresh ourselves with some basic concepts of the measurements of angles. Typically in trigonometry, we express the measurements of angles as degrees or radians. And it is important to know how to convert these measurements to and from each other. Now, let's first discuss degrees. Here, one revolution of a half line on its endpoint is equal to 360 degrees. And 1 degree is equal to 60 minutes. And 1 minute is equal to 60 seconds. This will be useful later on when converting to and from radians. Now for radians. Here, one revolution of a half line on its endpoint is equal to 2 pi radians, and pi is equal to 3.1416 and so on. And based on that one, half revolution is equal to pi radians. I suppose let's convert 450 degrees into radians. The first thing that we should think of is converting it first to revolution, since it's the common unit between degrees and radians. Let's put the unit revolution on the numerator and the degrees on the denominator, so that we could cancel out the degree units, and we will be left with revolution as the unit of our answer. Now let's convert the answer, which is 1.25 revolutions, into radians. Now we want to cancel out the unit revs, right? So in order to do that, we will put the conversion factor of revolution on the denominator and the radians on the numerator, so that we could arrive at the final answer of 2.5 pi radians. Now let's try another example, but now let's solve it without showing the intermediate answer. by using the idea of canceling out the units in order to arrive at the final unit, which is radians. The first part, we can cancel the degrees, and on the second part, we can cancel the revolution. And we will be left with radians as the unit. And solving using a calculator, we will have a final answer of 0.1667 pi radians, or pi over 6 radians. Now let's try to convert this one. 60 degrees, 6 minutes, and 20 seconds. The first thing that we should do here is convert the seconds into minutes, minutes into degrees, then degrees into radians. Here we're going to convert first 20 seconds into minutes. We need to place a conversion factor where the unit seconds is in the denominator and the unit minutes is on the numerator in order for us to get a final answer that has a unit of minutes. Now the answer would be 0.3333 minutes. Now we're going to add this one to 6 minutes. We will have an answer of 6.3333 minutes. Now let's convert this one into degrees. Now using conversion factor where the denominator contains minutes and the numerator contains degrees in order for the units minute to be cancelled out. So the final answer contains the unit degrees. Now we're going to add this answer 0.1056 degrees to 60 degrees. And we have a total of 60.1056 degrees. Now we can convert this one into radians. Now using the same technique, the first conversion factor is we are going to convert degrees into revolution, and for the second factor, we are going to convert revolutions into radians. Now solving, we will get a final answer of 0.33392 pi radians. Now, what if the angle is negative? So there is no worries here because the sign only denotes the direction of the rotation, whether it may be clockwise or counterclockwise. A counterclockwise direction of rotation denotes a positive sign, while clockwise direction of rotation denotes a negative sign. So now, here negative 240, it denotes that the rotation is clockwise. Now the first factor is to convert degrees into revolution, and the second factor is to convert revolutions into radian. And degrees will cancel out and revolution will cancel out, and the unit of our final answer is in radian. Now solving, the answer would be 1.3333 pi radians. Now how about we solve radians into degrees? Here we apply the same concept of using conversion factors, where we need to find a way to convert the unit into another unit in order to find the final answer. Here we're going to convert radians first into revolutions, then revolutions into degrees. In solving, we have 600 degrees, but as you may know, one complete revolution is only 360 degrees. This means that this is greater than one revolution. Now, in order to get the equivalent, which is only less than 360 degrees, we need to subtract 360 degrees here, and we will get 240 degrees. And that is the final answer. Now, another example. 0.321 radians, using a conversion factor again, radians into revolutions, then revolutions into degrees. Cancelling out the units, radians, then revolution, we are left with a final answer that has degrees for its unit. And the final answer is 18.392 degrees. That's all for now, and for the next lesson we will discuss the Pythagorean theorem. Please like, comment, share, and subscribe, and thank you, and see you again.